Okay, guys, we are going to quickly go over your SGI do now and then head right into the mini lesson. So let's take a look at number 1. So we have Roberta. She went out to eat, and her food was $31.15. So I'm going to go ahead and her food was $31.15. There was an 8% tax on the cost of the meal, and she left an 18% tip on the total bill. How much did she pay overall? Okay, so I'm going to read this again, but first I'm going to double check. How much did she pay overall? So that means I want her whole bill, right? Including tax and tip. Now, she has $3.15, that's her original. Plus, she adds an 8% tax, that's an increase. Then she adds an 8% tip, that's another increase. Okay, so I'm going to go ahead and make 2 OPN charts because I want to do her bill with tax and then her bill with tip. Okay, so over here, so her original is $31.15. Her percent increase is 8%. And so her new is what I'm looking for. So I'm going to go over here and do original times percent to give me new. My original is $31.15. I'm doing that times 1.08, which represents the total cost of the meal plus 8%. Okay, and when I do that, I get $33.64. Now, that's not what I'm looking for. What I'm looking for is how much she pays, including the tip. So I have a new OPN chart. I'll do this in a different color. OPN. All right. So my new total is $33.64 plus 18%. And then that's going to give me my total bill. So I'll do my original times my percent, and it's going to equal my new bill. Okay, so my original $33.64 times 1.18. So that represents the bill with tax and the tip that I'm adding. And when I do that, I'm going to get 39.695. So I'm going to round that up to 39.70. Okay. I'm going to look over here. Yes, that is an option, 39.70. Okay, so the person who would pick 33.82 or 31.07 would have been somebody who either stopped at the tax increase or did something funny with their calculation. That 56.07 would be if we had somebody who made a really weird calculation where they added 18% plus 8%. So our answer here is 39.70. Make sure you have that on your paper. And we're going to take a look at number 2. Last year, the price of a computer was $565. This year, the price increased to $615.85. By what percent did the price increase? What percent did the price increase? This is asking me for a percent. My answer is going to be a percent. I said that twice because this is the kind of question where you guys will sometimes know how to do the math, but you just didn't read the question correctly, okay? So my original here was $565, and my new price was $615. So in my OPN chart, what I do not have is my percent increase. So I'm going to put that over here, OPN. Okay, I know that my price here was $565, and I know that I landed at $615.85. What I do not know is my percent. Original times, I'll put P for percent, is equal to new. All right, so that's going to be 565 times P is equal to 615.85. And what I will do is divide both sides by 565. 565. Divide this by 565. And what I'm going to come up with is P is equal to 1.09. All right, but that doesn't mean that that's my percent increase. That 1 represents the 100%, the 565, and the 0.09 represents the percent increase. So my percent increase is 9%. All right, yep, that's here. So this problem, or sorry, E was hoping that you didn't know how to read that 0.09 was 9% and not 90. G was hoping that you understood that you had to change the decimal into a percent, and so was H, hoping that you understood how to change the decimal into percent. So your price increase was 9%. Okie dokie. And we'll do this one commission problem here on the do now. Reed gets a base pay of $1,100 per month. He also earns a commission of 10% of the total sales in dollars that she makes. It's a he and a she. Fine. He or she. What are Reed's earnings for a month in which he has sales of $29,000? Okay, so I'm being asked about the total earnings. All right. So what does that mean I need to do? Okay, so my KIB is actually going to have here, I have a base pay of 1,100, okay, and then I'm going to do my OPN chart. My original here is 29,000. The percent he gets is 10%, and then it's going to give me my new, okay? So this is a case where I'm going to go ahead and first find my commission. My commission. All right, I have original. Whoops, I don't know why I always make that a T. Times percent is equal to the new. So my original here is 29,000 times 0.1, and that's going to equal my new. So my 29,000 times 0.1 is going to give me 2,900. Okay, but now I have to add that to the base. So I have my base pay plus my commission, base plus commission, and that's going to be 1,100 plus 2,900. Okay, and so that's going to give me his total earnings of $4,000. So these are hoping that you make a series of calculation mistakes or that you just add one earning to the total sales. So we didn't fall for any of those. We're going to choose the right answer, which is 4,000. Take a moment and make sure you have that. And let's get ready to flip over to our mini lesson, which is in the same sort of vein as what we've been doing on the do now. These are percent problems that have multiple steps. So when I'm doing a percent problem where I have more than one step, where I need to find more than 1%, or there's some base pay that I need to add in, the organization of my work is critically important. And because I'm working with a computer thing, it's going to be a little bit easier for you guys to organize your work in pencil, just because you can do more with the space than I can with my computer program. But I really want you to make sure that you're organizing your work in a way that will prevent you from making a silly math mistake, because you guys do know this math. So let's take a look here. Hannah earned $160 from her job yesterday. Today she expects to earn 12% less than yesterday. Tomorrow she expects to earn 12% more than today. What is the combined amount, also known as total, that she expects to earn for those 3 days? Okay, so here again is where I need to take my original number and do a few things to it. So for yesterday, she earned 160. So for today, she is expecting to learn 12% less. So my OPN, zip, zip. My original is 160. She's earning 12% less. And that's going to give me my new. Okay, so I'm going to put original times percent equals new. And if she's earning 12% less than 160, that means that she's earning 88% of that. So I'm going to multiply this by 0.88 by 88%. And so when I do 160 times 88%, I get 140.8. Okay. Now, she thinks tomorrow it'll go back up 12% from what she earned today. So my tomorrow number, let me put tomorrow here, I'll do it in a different color. Tomorrow. I need to take for my OPN what she earned today. Okay, so I am not putting 160 there. I'm putting 140.8, all right, plus 12% is going to give me my new. So I'll do my original times my percent is equal to my new. And in this case, my original is 140.8 times 1.12. Okay, so that's the 100% plus the 12%. That's how we represent the increase. And I'm going to get 157.696, which I will round to 157.70. And there I might want to go, woof, I'm all done because I found how much she's going to make on each day. And congratulations, we did. But that's not the question. The question is, how much is she going to make all together? So I have yesterday plus today plus tomorrow. And that's going to be 160 plus 140.80 plus 157.70. And so my total that she earns over those 3 days is 458.5. So she earns, or he, $458.50 over the 3 days. Okay, and I'll put a little box around it. Oops. You'll put a much neater box than I did. All right, so let's review really quickly what I just did here. I have my original price from her job yesterday, okay? And she said, okay, today I think I'm going to make 12% less. So I found 12% less of that 160, which gave me 140.80. Tomorrow, I think I'll make 12% more than I make today. I used that 140.80, all right, because that's my new original number. Found that 12% increase. Tomorrow she makes 157.70. Added those all together to get how much she makes in one day. So what's sort of our key takeaway here? After we apply the percent increase or decrease, we create a new value. Okay, so for example, when I paid my tax on my lunch, I created a new value. So therefore, if we need to provide another percent increase or decrease, we may need to use the new value we just created, but now we use it as an original value. Sorry, my pen's being a little funky. So after I have my first new value that I've created, so that's my lunch plus my tip, or sorry, my lunch plus my tax, I have a new value then where I might want to add a tip on top of that. So I have to use that original as the new value. Okay, you guys are going to head into partner practice. You're going to head into independent practice. And I will go over number 5 on the independent practice at the end of class. So good luck. Get to work. All right, guys, welcome back. When I said number 5, I really meant number 4. So let's take a look at number 4. Here we go. Baker Aker is trying out new recipes for his chocolate chip muffin. In batch A, he uses 112 chocolate chips. In batch B, he increases the number of chocolate chips by 20%. In batch C, he uses 10% fewer chips than in batch B. Approximately how many more chips does Baker Aker use in batch C than batch A? All right. And so this is one of those problems that's like really just mean, right? Whoever wrote this problem just has an evil streak inside them. But I'm really glad that they did, because the people who make our state tests have that same little evil streak. In fact, I'm just kidding. These are all lovely people. But this is a weirdly difficult problem, okay? Not because of the math, but because of the wording. So let's break it down, okay? I need to find how many chips are in batch A, batch B, and batch C. And then I'm going to have to do a subtraction problem. Okay, so let me start down here with batch A. And my OPN for batch A is that I started with that 112 chocolate chips. My percent increase from batch A to batch B is going to be 20%. And then I'm looking for my new. So I'll write over here, original times percent is equal to new. My original is 112 times 1.2. That's for 120%. Okay, and so, oh, that's a 12. Sorry, it looks like a 7. My new total is 134.4, right? We don't have one for 34.4. So, and in fact, you know what? I did a really big boo-boo here. This is actually batch B that I'm finding, okay? Because batch A we know up here, and I'll make batch A a different color. Batch A has 112 chips. All right, and I'm using that number as my original here. Okay, but now to find batch C, let me scooch down here a little. Hopefully I have enough room. I'll do a new color. I'll do red. For batch C, my OPN, I'm going to use this number as my original number. So that's going to be 134.4. All right. My percent is a percent decrease of 10%. And then I'm going to find my new, that's what I don't know. So I'll do my original here. Times percent equals new Messiah. Why do you write that every single time? We've seen you write it 100 times because it really helps me organize my work. That's why I write it every single time. Okay, so my original in this case is going to be 134.40 times 0.9, because if I'm taking 10% off, that means I'm using 90%, and what I'll get is 120.96. Okay, I'm obviously this baker who puts very specific amounts of chips in his muffins is not going to cut chips up to get 120.96 of a chip, so I'm going to round that up to 191. Okay, and so my question here is about equal to 191. Is, I have to go back to that question again. Approximately how many more chips does Baker use in batch C than batch A? So now I take that batch C. Sorry, I totally rounded that wrong. I totally was looking at the wrong thing. Let me go back here. Forgive me. So that's 121. Okay. So now I'm going to take batch C minus batch A. So that's going to be 121 minus 112. All right. 11, 10, 9 minus 1. All right. So he uses 9 more chips. And my answer is D. And I have to go back and double check this now because whoever made the key actually put the wrong answer. They got tripped and they stuck with 121. So my question is not how many did he make in batch C? My question is how many more chips does Baker Acre use in batch C than batch A? So this was the critical step that the brilliant mathematician who made this key skipped. And so if a brilliant mathematician can do it, so can all of us.